thank you so much for joining us, Lunch Break Science. Today, we brought you a panel of brilliant scientific researchers who are applying artificial intelligence to questions around climate science and extreme weather events, energy, and the criminal justice system. So we're so thrilled to be joined by several of these brilliant researchers. But to introduce our first speaker, what we're going to do is actually going to hand it over to the speakers, give short talks about how they use AI in their work, and then have host a series of questions that Catherine and I and the panelists have developed together, and then hopefully turn it around to the visitors, to the guests near the end. So with that, Catherine Branson, our scientist in residence. Dr. Branson, would you please introduce our first speaker?
Hi, thanks, Jeremy, and thanks everybody for being here. This is really exciting to be a part of this panel, the first of its kind. And so it's my privilege to introduce Dr. Ariel Ludwig. Dr. Ludwig, could you please introduce yourself and tell us a little bit about the research experience you have with AI?
Sure, yeah. So my research, I'm a recent graduate from Virginia Tech's Science and Technology Studies program. And my research focuses on the criminal justice system and technologies used in the criminal justice system. Today, I'm going to talk about predictive policing and the use of machine learning to predict crime. I will begin by talking about location-based predictive policing, which is really the vast majority of it at this time. So today, predictive policing plays a central role in intelligence-led policing around the globe. Current predictive policing platforms utilize machine learning, which Mitchell defines as the study of computer algorithms that allow computer programs to automatically improve through experience. The National Institute for Justice, or the NIJ, has given high praise and support for this approach, touting that it harnesses the power of information, geospatial technologies, and evidence-based intervention models to reduce crime and improve public safety. By moving law enforcement from reacting to crimes into the realm of predicting what and where some and resources according. Between 2008 and 2014 alone, the NIJ awarded almost 256 million grants for the adoption, implementation, and evaluation of predictive policing technologies. Recently, predictive policing tools have come to be integrated into larger law enforcement, records management, intelligence, evidence tracking, and crime analysis platforms provided by large corporations such as Palantir, LexisNexis. However, predictive policing has come to be questioned by public, professional, and academic communities. One of the strongest criticisms suggests that it perpetuates the criminalization of marginalized populations that have been over-policed for decades, thereby masking old prejudices and new technologies. So the other type of predictive policing focuses on individual people, and this is called person-based predictive policing. And instead of identifying spaces, this actually identifies people. So person-based predictive policing uses personal characteristics to identify those at greatest risk of committing crime or I guess I should say, and or becoming a victim. And it's important to also note that predictive policing technologies draw from a wide variety of data sets. And these include everything from computer aided emergency dispatch to health data by area, and just a very vast amount of data, which you can read through the different sources there. However, it has been noted that data in these systems are also subject to human error, and many of the federal databases are limited due to state participation. So what does this look like on the ground? Predictive policing platforms typically provide officers with 500 by 500 foot high-risk plots to patrol during their shift. The instructions as to how to patrol these vary, with Predpol, which is one of the main companies that provides predictive policing technologies, suggesting that officers spend 10% of their time on their shift in each of the highlighted squares. And there's an example of this given in the map there. And in turn, a lot of these systems and platforms are actually integrated so that they actually monitor either the GPS in the officer's phone or the automatic vehicle location system to determine to what degree officers are complying with this. And so therefore, it also has the other side of this is that it also provides oversight to officer and use of these technologies. All right. So one of the gravest concerns about predictive policing is that it can lead to violations of a person's Fourth Amendment protections against unreasonable search and seizures in such a way that disproportionately affects marginalized people and communities.
We got a short introduction to how AI and predictive policing works. And so now we're going to hear something completely different from my colleague, Dr. Maria Molina from the National Center of Atmospheric Research. Dr. Molina, would you introduce yourself to our guests and tell us a little bit about your research experience with AI?
Absolutely. Thank you so much for having me. It's a pleasure to be here and to get to talk to everyone that's here today about some of my work and how I use AI, and also a little bit about myself. So I'll go ahead and share my screen now. And so I wanted to explain first what the National Center for Atmospheric Research is. I assume maybe some people have not heard of this center. So we are based in Boulder, Colorado, and here is our laboratory. It has some great views. This is me outside our lab. When I used to go into work, we are not for the moment going into work, and we are still closed to the public. So we do allow folks to visit, and we have a museum in our lobby to share some of our climate research. But the MCAR mission is characterized by 3 pillars. So our goal is to better understand the behavior of the atmosphere and related Earth and geospace systems. We also work to support the university and broader scientific community. And another important task or part of our mission is to transfer knowledge and technology for the betterment of life on Earth to those same other communities as well. And so before working at the National Center for Atmospheric Research, I had a slightly different career. I actually worked as a broadcast meteorologist. So this is me out here standing in the snow, covering a historic winter storm. This was actually in Buffalo, New York, about 5 or 6 years ago now. And so there were over 5 feet of snow that fell in this region, which was just absolutely crazy. And so now I've transitioned over to a research scientist role where I still get to speak to the public and to other scientists, but my setting looks a bit more like what you see on the right-hand side of the screen now, where I'm sharing slides very much like I am right now, and communicating some of my research results. So what is my research about now? So I focus on applying artificial intelligence to extreme weather events and also to climate problems. So the type of artificial intelligence that I use oftentimes involves something called a convolutional neural network. And what's so great about this type of architecture of AI is that we can feed it in spatial data or information of weather or climate into these and stack them into little cubes like this. And we get to slide a filter around that gets to analyze some of the spatial features of our data, also looks at some of the variables, and can output a result based on what it is that our goal is for that specific problem. So I have worked on classifying thunderstorms. So this is here a modeled thunderstorm from one of our high resolution model simulations. And so I work on classifying these storms on whether they may be producing severe weather or not, severe weather being things like tornadoes and large hail. And I also work now on climate prediction. And so trying to predict climate patterns such as the Madden-Julian oscillation or ENSO, and trying to see how these patterns relate to extreme weather events, or what upstream processes may lead to these events. And so that is essentially my research in a nutshell. And if I had to explain machine learning to someone, I believe the question was in third grade, possibly, I would say that machine learning helps us learn a lot of information from our data. So we give a ton of data to an algorithm. I guess that's not a very good explanation, but essentially we're just trying to get help on processing all of the data that we have, because we as humans may miss some important information or some details that could really help us learn many new things about our data. And so we hope that using AI, we can do good and make life on Earth a bit better for humans by understanding our atmosphere and our climate system a bit better. And that's all. Thank you.
Wow, thank you so much, Dr. Molina. That's fascinating to see someone that we have several local meteorologists that I bet a lot of folks on this call know and love, and to see your transition into now doing AI research, that's really interesting. Thank you for sharing that. We'll get into more about like how AI can make the world better in the discussion questions, but I'll pass it back over to Dr. Branson to introduce our final panelist, and then we'll get into questions.
Yeah, it's so interesting to hear about how AI is being used, and a little bit of understanding of what exactly we mean by AI by getting these introductions. And so to continue that, I would like to pass this over to Louis Labrie. Louis, can you introduce yourself and tell us a little bit how you're using AI?
I'm Louis Labrie. I'm an innovation consultant and educator. My background is in AI is a little difficult to explain, so I thought maybe I would run you all through a little thought experiment today, instead of kind of just throwing some complicated situations at you. So I'm going to pose a really strange question. What do you think is common between forks and batteries? What do forks and batteries have in common? So just take a second and think about that. So immediately you're probably thinking there's not a lot, that this guy's crazy. Obviously there's nothing similar between batteries and forks, but I actually think there's a lot in common. Both forks and batteries are tools. And not only are they tools, though we don't think of forks being tools, they're tools used for efficiency's sake. So what does that mean? Forks are basically used to help us eat a meal in an easier way. And easier many times translates into more efficient. Similarly, batteries are a tool we use to power our world in a more efficient way. So think back to all the things that are powered by batteries: electric cars, phones, laptops, backup systems for buildings, even small scale backups and auxiliary power for cities, all powered with batteries. But there's one major difference between forks and batteries, is that we don't use forks to eat an entire meal. Imagine that I invite you to my house. Thanksgiving's coming up, and I decide I want you all to join me for this annual meal. So you all come in. It's a very big table. I don't know how many people there are, but you all come in and you sit down and you see this beautiful meal, and I offer you only one utensil, a fork, to both serve and eat the entire meal. Not very efficient, pretty messy. It's you're going to think I'm, again, crazy. But similarly, batteries but we have discovered through time that we can make tools and other utensils to help us eat this meal. So spoons, knives, ladles, a number of tools, each with their own unique set of strengths and weaknesses for serving and eating the meal. This brings me to finally my work with AI, and it was formed by a single question. What if we could view and choose the most efficient tools in an ever-changing world for our energy needs the same way we look at a meal and choose which is the most efficient utensil to eat each food type? Just like eating utensils, we've come up with hundreds and even thousands of energy harnessing and storage formats. Batteries, capacitors, fuel cells, geothermal, hydroelectric, solar, wind, each with a unique set of strengths and weaknesses. And many times we use these energy formats in a very inefficient way, either singularly through like using just one to power either a city or a vehicle, or maybe two based on some outdated annual usage data. So my research and technology is on taking real-time data and making rolling predictions through the use of AI based on which available energy source is the most efficient in a given time, cutting energy waste and making a cleaner, more efficient world. So that's it for me. As far as what my background is, I'm going to pass it back over to Catherine.
Thank you. Let's see here. So I think what we're going to do is ask a few questions that we've prepared for our panelists, and then hopefully we should have plenty of time to get some questions from you, the audience. So feel free to be sharing some of those questions in the chat as we go along, as those occur to you, and then we'll get to those in just a little bit. But I'd like to start out with how does AI improve over what humans or traditional computers can do? I'm going to start with Lewis, and then we can pass that around.
Thank you, Dr. Branson. So artificial intelligence, in my opinion, boils down to a complex pattern recognition tool. So when people picture AI, I think they picture robots having emotions and things of that nature. We're not quite there yet. Right now, we're just in the pattern recognition stage. Humans are uniquely suited for abstract thought. This helps us make art and music and culture, technology, religion, philosophy. All of those things come from abstract thought. We can make intuitive leaps based on illogical sometimes data or conflicting information, which is very difficult for AI, and simulate our futures in very complex ways. What humans are not great at but we sometimes think we are, is concrete thought. It's literal, logical, and based on here and now. So we use machines to enhance our understanding of the world and make connections between data far-reaching for the human mind. I believe that Maria will be able to give us a little glimpse at like the complexities of the data that she sees in her research. I know storms for sure are very complex and have a lot of data coming in. So, for me to look at a radar scan and say, oh yeah, there's going to be a hailstorm, that's exactly what AI is better suited for.
Thank you, Lewis. Actually, speaking of, Maria, would you like to pick up where Lewis left off and tell us a bit about how AI can improve on weather forecasts or climate models or anything like that?
Yeah, thank you. And thanks, Lewis. That's right. It's a great pattern recognition tool. And I would add that at least in atmospheric science or system science, what's really great about AI is that not only can it harness all of this data that we have and help us analyze it in a much more effective way that perhaps we would be able to, and in a much quicker way than we would be able to. But AI, yeah, it's just, it also helps us detect, let's say, features. Before machine learning, let's say convolutional neural networks, I mean, AI has been around for quite some time, but oftentimes what we would do as scientists or atmospheric scientists, let's say if we wanted to identify an extratropical cyclone in data, we would come up with certain rules and criteria that would help us detect that feature. And so we would say, oh, pressure needs to be below a certain number. This needs to be a certain size. And the issue with the Earth system is that many times features don't meet all of these rules or criteria. And especially when we're looking at extreme weather events, they might lie outside of that, or they just might be an event that occurs that's very unique. And so in our rule-based system that we use to identify that feature or predict that feature, we might miss those events. And so this is something that AI has been helping with, because it's able to generalize some of these features or criteria that we use, and it's able to just learn from the data. And so I think that's one of the unique ways that AI has helped us, in addition to all of the other ideas that I've mentioned in this talk so far, or in this panel so far.
Well, thank you so much for that information. I think what's interesting is the idea of, like, if we might miss something that's there, and the ability for the computer to kind of detect it, but it's all ultimately based on what we tell the computer to find. And so I guess something that came up in our discussions before this were about the idea of bias. And so we all hear about bias in our everyday lives. Choosing one color over another is a form, like our favorite color is a bias. So actually, this is a question directed at Dr. Ludwig. Ariel, what is bias in the world of AI, and why does it matter, especially in your work?
Yeah, sure. So in thinking about the complexities and the connections that are being made, one of the important things I think to account for is bias. And bias is broadly defined as a prejudice in favor or against, and in science and engineering, refers to a systemic error. Now, what does that mean when we apply it to predictive policing? There are many, many implications, but some of them include that predictive policing relies upon historical data. And so when considering that communities of color have been disproportionately policed and incarcerated, this means that the projections of the future are at risk of reinscribing the past. The classic example is that when there are crime maps, such as the one behind me, made of New York City, they don't have hotspots around Wall Street, for instance, even though that would be a place where there are high rates of crime, of white collar crime. Second, the data itself may be problematic in terms of accuracy and ingrained assumptions. Here, it's important to note that demographic characteristics are socially constructed. And this is reflected also, you can kind of see this in how these categories have changed over time. So they're not set and given. And I think when we forget that humans are making this data, they're entering it, they're deciding which category things go into, what data is included, and what data is absented. This is a place in which we can come to have bias. Third, given that most predictive policing tools are proprietary, meaning that they're owned by corporations, oversight of them is not always possible. And that means that communities that have this tool that are being used in them are not always able to give feedback on how it's working, what are the logics that are being used, so on and so forth. And then the fourth one is that responses to these models remain neatly, to date, within the scope of law enforcement. So the response to hotspots is to send law enforcement. It's not to send social services, an influx of social services, or community engagement and things like that. And so each of these places are, you can kind of see are places where our bias comes into them, and set logics and responses can be seen. And I know it's a little bit different in the work of my other panelists, and especially when it's not applied to humans. So I'd love to hear more about bias in their work as well.
Thank you, Ariel. Lewis, could you maybe follow up? And do you have any thoughts on how bias can influence AI?
I think that, our Dr. Ludwig makes some really great points that, we say in the data world that if you have garbage in, you get garbage out, right? So if you're getting biased people or biased data coming in, you're going to get biased results, right? It actually makes me think back, and this doesn't have anything to do with my research, but this makes me think back to the project done by Amazon quite a few years ago, where they basically decided that they were going to hand over their hiring to AI so that they would avoid, hiring on one side or the other more as far as gender, race, sexual orientation, that sort of thing. And then they found, because they were feeding it past data from the company, that the AI was biased towards hiring men because the company was actually biased from hiring the men in the past. So, that's really a crucial thing for all data science and all AI. In my field, I'd say bias would more come in the form of corporations and things wanting to skew data to see a certain result. So it's the reason you don't have a test engineering team and a design engineering team in the same building, right? You have your test engineers, they want to test and make sure the thing is failing, and you want the design engineers to think their thing is great. What you don't want is a design team to test their own system because they're going to be biased and say, oh no, this thing's perfect, push it out the door, and then the results become catastrophic. So as far as bias goes, I think it's more of, for our fields, and I'll let Maria speak more to this on her side, but for our fields, maybe it's not so much human bias, but skewed data for whatever reason, collection methods or incorrect labeling, human error, things like that.
Mm-hmm. Thanks, Lewis. I'm actually going to go ahead and move on to our next question, although Maria, if you had any particular follow-up, then let us know. But I wanted to ask you, Maria, to start us off on what are a couple ways that AI has advanced your field?
Great, thank you so much for the question. On bias, I will briefly add that we're learning a lot of information from our data, and one of the many tasks in AI and in weather and climate is on the issuance of warnings for hazardous weather. And so this is a place, or one of the many places, but one specific place where bias can creep in, and we have that societal input now because these warnings will impact humans. And so understanding how humans would interpret that information and making or ensuring that that bias doesn't creep in from all of the societal labels that we have issued and things like that to try to represent demographics in our data. We really need to make sure that we are very careful there, because these are important warnings and important information that really has an impact on humans. And so two ways that AI has advanced our field, I would say one fascinating way is it includes the replacing parameterizations in models. And so what on earth does that mean? That means sometimes we'll run a dynamical model, not a machine learning model, but a model that will predict how, let's say, a thunderstorm will evolve. But there are some really tiny processes occurring that are, let's say, within the updraft of the thunderstorm, how hail is forming, and much smaller scale that we're just not capable of resolving because we don't have that data. We don't exactly know how some of these processes are occurring still, and other factors that come into that. But AI has actually been able to learn from other data that we give it and is able to represent these processes in our models. And so I think that's one very exciting way moving forward, because these parameterizations have really limited the skill in our models. And so hopefully we see continued improvement in these models moving forward with the help of machine learning. And then the other way that AI has advanced our field, I think I've mentioned already, which is that we have an increasing amount of data. And so this includes data now from drones that can just operate on their own across the planet. We also have satellite data that has increased in resolution, both spatially and temporally. And there are also new instruments being launched, such as recently, a few years ago, the geostationary lightning mapper that can detect lightning flashes across the full disk of Earth. So that's a lot of information. and so machine learning helps us pick out patterns, not just how, let's say, they look spatially like a thunderstorm, but also how a certain feature is evolving in time. And so as we continue to get all of this data, we can use machine learning to help us learn new information from our vast amounts of data and new instruments that continue to be created and launched.
Wow, that's fascinating to hear about, like, the small scale. I mean, like, so many, it's so interesting, like the idea that we have to set in our traditional computing, like, and forecasting, we kind of have to make a really educated guess at how these things work. But the machine learning can spend its whole purpose is to figure out that guess way more exactly than we can. It is kind of what I'm getting from what you're saying. And please correct me if I'm saying that incorrectly. It's just fascinating.
That was great. Good job.
Well, that's so. I would love to hear. I think we just staying on. Do Ariel or Lewis have anything that they want to make sure that they say about how AI has? Maybe Ariel, if you want to speak to. I know it seems like there's been a lot of criticism of predictive policing, and you've made a very good case as to why. Do you have examples of how it has improved the criminal justice system in a demonstrable way?
Sure. I mean, I think that one of the things to think about as well is that there are tools that are sort of counter mapping tools as well. So some of these include police violence mapping and identifying officers at risk or at higher risk. And these are similar models, are at higher risk of having either violence or a deadly episode, things like that. And I think that one of the things to think about is the way that these sort of logics and rationalities work, right? So it's looking at if-then sort of patterns and associations between things. And so I think it does reflect in many ways the way that the criminal justice system has worked historically. And I think it brings about a lot of questions about, what should that look like? How should we think about liberation from specific patterns, right, that we see repeating? How can we think about expanding into sort of more spectrumal or spectrum spaces versus binaries? And so I think that it raises a lot of questions, and that it gives a lot of fruit for thought in the field.
It's fascinating to hear, and with so much discussion around policing and experiences in cities all around the country. I think that this work, I think we'll continue to hear more and more about it. So it's one of those things that it's so fortunate to have someone with such a deep understanding of not only the criticisms, but some ways that it can be used in a positive manner as well. So that's great. Thank you for that. I'm going to switch us over to, speaking, we've talked a little bit about bias, and this question goes to Lewis. is like, what are some, I would love to hear about how in like energy management, like what are some limitations of the use of AI in understanding energy systems?
Thanks for the question. I think that's great. A great question. We have a data problem. So that big boom of, I think we've all heard the term big data, right? Where everybody just wanted all the data they could get. But what they didn't realize was not all data is equal, and that we need to label and make sure these pieces of data are actually helpful to us. I think that's the biggest issue right now in my field, is that there's a lack of understanding of why all this jumbled data that's been collected over the last 20 years is useless. We're trying to reinvent those collection methods and make better predictions about what types of data we're getting. The other limitation is it's sort of a double-edged sword with energy and data, right? Data is not, it has a footprint. It doesn't come from nowhere, right? So all the data we collect, right? So we have to have a balancing act of how much data are we taking, and is it actually helping us achieve our goals of being more efficient? If we're just collecting data constantly and creating a larger energy footprint for our data, then it might be negligible, the savings that we're getting. So we need to really we were doing a shotgun approach where we said, give us all the data, right? Like let's just shotgun it. Like, yeah, sure, let's take all that data. And now we're realizing that maybe we need to kind of hone in on specific data and what data is actually useful. So I think that's the biggest limitations in my field.
Thank you, Louis, for that. Maria, same question, some limitations of AI in the field.
Thank you. Yes, I was hoping I could add in because a very active area of research for us now involves making sure that our models are learning and predicting based on physical information and not violating like fundamental laws that we know exist in the Earth system. And so this can be done in two ways. One way that we've been doing this is taking a model that's already been trained on data and is already producing predictions and taking a look inside the model. So trying to break away from that black box, right, that people tend to call machine learning models. And so we take a look at whether what this model has learned is based on physical reasons that we know should be correct, right? And then another way that we can do this is by applying physics-informed models, where before training the model, we find ways to embed physical information or equations into these models so that these predictions can be based on some of this physical knowledge that we already have, right? So we can help our model along in the learning process. So this is a challenge and an opportunity for research and continued improvement, but it is something that's a big concern now. Again, just making sure that machine learning is actually learning physical information that we care about and need to make sure is in there for our predictions and our understanding of the Earth system.
Thank you, Maria. Dr. Ludwig, you've talked a little bit already about some of the limitations, as you've talked about your research. So please feel free to add on to what the other two have said, but I wanted to kind of move us along to the next question as well. I think, and this moves us into some sort of fun questions, some of which I've heard from some of our audience or from other people. And some people are worried that AI will steal their job. And so I want to know, are you worried that AI is going to steal your job in the future?
So I have to say that as I think about the sort of philosophy behind, this technology as well as the social implications. It may not work so well for my specific line of work, but I do have to say that it genuinely does shift the way that fields operate, right? So I went to a conference with crime analysts, and much of their work prior to predictive policing technologies they talked about was this sort of, trying to model and predict where they should allocate resources and allocate the resources of their department. So for them, it was really interesting to hear about the ways in which their work had shifted, in some cases to look at more cybercrime and the sort of like dark web. Actually, there was quite a lot of the shift that was taking place, according to them. And so as their roles were changing, I think it really changes the way that policing works and the way that the criminal justice system works. And I think that always can sort of shift the way that humans are allocated and work with that. And I think that it raises a lot of good questions about how we can kind of plan for that and intentionally sort of think about the ways that human energy and resources are valuable and can be allocated.
I love it because I worry about this all the time, that the museum world, hopefully there's something always there for a human to make sure that the computer's doing it right, so hopefully we're all reasonably safe in our work. Now I wanted to kick it over to Lewis. Do you think that AI can take over the energy sector? I mean, or are you afraid of losing your job?
Well, I've changed careers so many times, so I'm not really worried about it. But no, I think that as far as the need for engineers and in energy, I think eventually, yes. Right now, we're kind of limited in our growth of AI. I mean, we've seen a lot of growth over the last 20 years, and with Moore's law kind of slowing now, which if no one is familiar with that, it's the theory that computing power doubles every 2 years. So we're seeing that slow, and I think it's going to be a while before it takes people's jobs, but I could definitely see it taking some energy jobs for sure.
Well, thank you for that, Lewis. All right, so we've got 10 minutes left. So Catherine and I decided to make this last question a lightning round. So in 30 seconds or less, we're going to have each one of our panelists answer the following question. We're going to start with Maria. Dr. Molina, what is something you think most people don't know about AI?
90 to 95% of our time working with AI and machine learning is spent on pre-processing our data, not even training our models.
So you're working in advance to make sure that the computer even understands what you're telling it. Is that kind of?
Yep, making sure that our data is cleaned. So finding any errors in it, correcting any issues that occurred as these instruments were recording meteorological information, or making sure our output is correct. Yeah, that takes a tremendous amount of time, and is, at least in my experience, most of the work that has gone into machine learning.
Well, thank you for that, Dr. Molina. Dr. Ludwig, what do you think is something that most people don't realize about AI?
So I think one of the biggest things is thinking that it provides answers about causation as opposed to association. So I think a lot of times there's confusion about when we look at all of these vast amounts of information, does this variable cause this, or versus looking at the fact that it's looking for patterns and associations between.
Wow, so the relation, it's the relationship between two things, not necessarily one causing the other. All right, Lewis, same question for you. What's something most people don't know about or misunderstand?
Our most powerful AI has the brain power of an earthworm. So I think that people kind of picture AI being this, new, like, amazing thing that's going to solve all our problems, but it's harder to teach an AI than it is to teach a child, because all those constraints that you think that are inherent and common sense, the machine doesn't have any of that. So.
Wow. Well, the next time I feel challenged by my Google email account, and like I'm not good enough to write my own emails, I'll recognize that it's really just an earthworm creating those sentences for me. So thank you for that comparison. I love analogies like that. Catherine and Jim, I think we have just like about 6 minutes. Jim, do you have any questions from the audience in your inbox that we can?
Yes, we do have some questions in the chat, Dr. Hoffman. Thank you very much. I think this one is probably going to be more towards Dr. Ludwig. Can AI be used to predict and prevent massive Wall Street financial and economic crimes using predictive policing?
To be truthful, the models to date are not great for that. And in part, it's because of the amount of data collected and made available to these tools. So, and it's the same thing with sort of like large, like terrorist attacks or things like that, when they're very rare occurrences, or they're absent and have been absent from these models for so long, it becomes much harder. I think that increasingly these tools will probably be applied to things like that, but unfortunately, it's largely been a lot of like sort of drug crimes, street crime, violent crimes, things like that have gotten the vast majority of policing attention to date. So that's a great question.
All right, thank you, Dr. Ludwig. So we've got another one here. I think it was Dr. Molina mentioned recurrent neural networks. Could you explain a little bit more about those? Anyone on the panel?
Oh yeah. There's different types of architectures for machine learning models. So a recurrent neural network would consider a temporal sequence of information in our data. And so, for example, let's say if you're looking at lightning information, maybe there is a spike in lightning activity before a tornado forms or hail falls from a thunderstorm. And so a recurrent neural network would look at this temporal sequence of images or data that you feed it and hopefully learn some important characteristics of that sequence in predicting whatever it is that you're optimizing your task to be. So let's say predicting when a tornado will form. And then there's also different architectures. So let's say a convolutional neural network that I shared on my slide, which really considers more of the spatial component of data, and spatial and temporal data can be combined. And so there are certain models like convolutional GRUs, which is a data recurrent unit, which is just another type of recurrent neural network. And I'm getting into the weeds. But the point being that you can combine the spatial information and also the time sequence of information for predictions. Yes, it's very fun.
Anyone else on the panel have anything to add? All right, so we'll go to, I think this is going to be our last question. This one is for Mr. Labrie. How do you see AI assisting in energy conservation during extreme weather conditions such as heat waves or severe cold?
So that's a pretty difficult question. So my research was primarily on hybrid energy systems. So taking, like, let's say for an example, we developed a switching mechanism for switching between ultracapacitors and batteries in an electric vehicle based on driver data, right? In that kind of situation where you have a grid, taking like rolling historic data or rolling time-based data and saying, okay, when we're seeing these heat waves, we're seeing the need to shut down these certain transformers or these grids in this area and kick it over to like maybe an auxiliary system such as a battery backup or supplement that lost energy through, like, let's say a hydroelectric dam that's been that has potential energy stored. So that sort of thing.
Okay, thanks very much, Mr. Labrie. I think we're going to have to cut it off right there. Looks like we're out of time. Thank you all for joining us today, everyone on the panel. Thank you, Dr. Hoffman and Dr. Branson. Thank you, everyone in the audience, for joining us and helping us discover more about our world. Please join us next week on November 4th at noon, when my favorite neuroscientist, Dr. Catherine Franzen, will be back presenting pumpkin spice and everything nice. Very timely topic here at Lunch Break Science. As you can register for next week's talk at smv.org. Each talk is free to attend. It is open to the first 300 registrants. Thank you again for joining us today. Until next week, stay safe and stay curious.